Assalamu alaikum warahmatullahi wabarakatuh. So children, we have learnt factoring of quadratic equations and finding the roots using quadratic formula, right? So the two methods we have learnt. Now we are going to solve word problems based on quadratic equations. Okay, so here I'll give you one example. This is one example which is not there in your exercise, but they may ask it. Okay, and this is there in the textbook as an example only, it's there. Okay, so I'll just teach you how to do this problem. So this problem is normally referred as upstream downstream problem. Okay, so first let's understand what an upstream and downstream is. See, now you people know that when a river flows, see, there are two kind. One is when a river is flowing, it flows in one particular direction, right? So if the river is flowing, that it's flowing in one direction, and so the direction in which it flows, this side is the slow lower end, right, and this is the higher end, isn't it? So looking at the flow of the river and which direction it flows, we can make out that the river has got a higher end, which is the higher end, and which is the lower end, right? It's going on which direction. Now the other thing is, if you would have seen the lake and other pond and all, the water doesn't flow anywhere. The water just is stagnant, right? Like in this case, you look at this picture. This is a picture of a still water. Okay, so where the water doesn't flow, we call it as still water. Okay, that is, the water is stagnant. Okay, it's not flowing in any direction. All right, so now if you're traveling, if you're rowing a boat, let's say you're rowing a boat in this water, okay, in the still water. So the with whatever speed you are rowing, with whatever energy you are rowing the boat, with that speed your boat will move, right? That is in case of the still water. So whatever energy effort you put on rowing the boat, that much faster the boat is going to move, correct? So that is the actual speed of the boat. But when it comes to the flowing river case, okay, so let's say that the river is flowing in a certain direction and you are rowing a boat in that river, okay, and if your river is in this direction, see this, if your boat is moving with the flow of the river, see, like let's say the river is flowing like this and you are rowing a boat and the boat is also going in this direction, let us say. So what's happening? You're rowing a boat with a certain speed, but then the river is actually pushing you also, right? So your boat speed will be much higher than the actual speed, right? You will be using the same energy as you used in your still water, but then what is happening over here? Since you're flowing with the river also pushes you and you get an extra speed to row the boat, right? So this is a case of a downstream. You're going downwards. Understood? So this is the case of a downstream, like you go down like this. And if let's imagine that your river is moving like this and you are rowing a boat against the flow of the river, like you are going upward like this, all right, then what happens? Whatever effort you are rowing, you have to put a lot of effort to move upwards, because the water is actually pushing you downwards. But then with, if you are rowing it little harder, you can actually move upwards, right? So the speed of the boat in this case will be much lower than your actual speed, right? You'll be whatever effort you are putting, with whatever speed you are rowing the boat, that would be the actual speed of the boat, because the river is pushing you downwards. Okay, so you are flowing, going against the flow of the stream, right? So that is the case of the upstream. Okay, so in upstream what happens? The boat's speed will be little lower. Okay, so now you have got the picture. See, here you can see flow of the stream. If the flow of stream is in this direction and you are going the other way, other direction, it's the case of an upstream. Okay, and if the flow of the stream and your boat's direction both are in the same case, then it's going to be the downstream. Okay, and still water is the case where the boat is being rowed in the stagnant water. Okay, the water is not flowing in any direction. Okay, like in case of a lake, right? In Bangalore you would have seen many lakes, right? So these lakes here, whatever speed you are using, that will be considered as the speed of the boat. Nobody is actually pushing or stopping you, right? It's not, you're not getting any kind of a help from anybody, like in case of the downstream, the river helped you to move faster, or nobody is going to stop you also, right? So you are going to, the whatever the boat speed is, that's going to be the speed of the boat in still water. So you will be, these kind of words, still water, downstream, upstream, these terms will be used in your word problem, so you should know what it actually means. Okay, so now we'll come to the actual problem. See here, it says a motorboat whose speed is 18 kilometers per hour in still water. So see, it's in still water, that is, this is the speed of the boat in still water. Okay, it takes 1 hour more to go 24 kilometers upstream than to return downstream to the same spot. So what's happening? See, the motorboat speed is 18 kilometers per hour. Now this boat is taking 1 hour extra to go upstream. And how long is it, how far is it going? It's going 24 kilometers upstream. Okay, this is the distance. Okay, for to go 24 kilometers upstream, it's taking 1 hour extra than you take it to come downstream, because downstream you will come quicker, right? Because your speed is faster, the river is pushing you down, so you come really fast. So this, when you go upstream, you are taking 1 hour more, okay, because you're going little slowly. So now they are asking you find the speed of the stream. So they want you to find the speed of the river actually, okay, the stream. Sometimes they may say find the rate of the current. Okay, rate of current. This also means, when I say current, it doesn't mean the electric current over here, it's the speed, the river's flow, the streams, this thing. Okay, so rate is nothing but the speed. Okay, so they may ask they may write the sentence in this way also, find the rate of current. That means you just have to find the speed of the river. Okay, now let us write down what all is given. We know that the speed of the boat is 18 kilometers per hour. So I write S is equals to 18 kilometers per hour. And I also know that the distance is 24 kilometers. So I write this ET is equals to 24 kilometers. And then let us, whatever they are asking us to find. They are asking us to find the speed of the stream. So I will say let the speed of the stream be X kilometers per hour. Okay. So this is what I am supposed to find. Now, when I go downstream, what will be my speed? My boat speed is 18, but my actual boat speed will be the real boat speed in still water, and the speed of the river also gets added up, right? So I will get 18 plus X, correct? And distance will remain as 24 itself. And so time to go downstream, so the formula for time is distance by speed. So in this case, distance is 24, speed is 18 plus X in the denominator. Now when I talk about upstream, I will be having S is equals to 18 is my boat stream, but then my current, that is my stream, is actually pushing me downwards, right? It's like, I have to fight the flow of the current, and then I'll have to move upwards. So the speed of the stream is subtracted from the 18 kilometers per hour, which is my boat stream. Okay, it gets subtracted because it's becoming slower, and distance is the same, and you have time upstream is equals to 24 over 18 minus X, because here the distance is 24, but then the speed is 18 minus X. Okay, so now it says the question, look at the question, it says it takes 1 hour more to go upstream than to return downstream. So this is the speed downstream, and this is the speed upstream. So upstream is taking 1 hour more than downstream, right? Upstream is 1 hour more than downstream. So let us write. So that is time of upstream is 1 hour more than time of downstream. So T up is equals to TD plus 1. Got it? So now I'll just write down T up is actually 24 over 18 minus X is equals to T down is 24 over 18 plus X from here, and then plus 1. Now let me bring these two together. So I can just subtract 24 over 18 plus X. So now this gives you, so I have two different numbers over here at the denominator. So let me take the LCM again. Okay, I'll have to make the denominators common. So I'm actually multiplying 18 plus X over here and 18 plus X over here. This side I'm multiplying 18 minus X. So now both of them are having 18 plus X and 18 minus X. Okay, so now what do I have? I'll have to multiply 2 times 18 plus X minus 24 times 18 plus x minus 24 times 18 minus x in the numerator, the whole thing divided by 18 minus x and 18 plus x, okay, because the denominators are same, is equals to 1. Now you multiply this and check. 24 times 18 is 432, so I have done it directly and I have written it down. You can cross check it if you want. 24 into x is 24x, minus 24 into 18 is 432, again plus minus into minus plus 24x. Now at the bottom I have got 18 minus x and 18 plus x, which could be written as 18 square minus x square. It's of the form a plus b. If I have a plus b, a minus b, I will write it as a square minus b square, right? A plus b, a minus b could be written as a square minus b square. So I will directly write it as 18 square minus x square. So that's what I have written, and I can move it to the other side, so it gets multiplied with the 1. So I get 18 square minus x square. So now this, you see, 432 minus 432 gets cancelled. 24 plus x, 24x plus 24x becomes 48x is equals to, this 18 square is 324 minus x square. So now you bring everything together. So this is minus x square, I can bring it to the other side, it becomes plus x square. So I don't have to write a plus sign. And then plus 48x, I'll write it as it is. See, here nothing is there, so that means there is a plus over here. And minus 324 is equals to 0. So now you can use your splitting the middle term or your quadratic formula, whichever method you feel is better, you can do it. So I have just used quadratic formula. So a is 1 and b is 48, c is minus 324. So I use this formula and I will substitute the values, okay. So when I substitute the values, see, I got 48 square as 2304, and I have multiplied this, and see, you get minus and minus is plus, right? You are getting a plus over here. So then you get inside the root, you get 36,000, the 3,600 or 3,600, right? So 48 minus 48 will be kept as it is, plus or minus 3,600 could be written as, see, the square root of 36 is 6, and 2 zeros could be taken as 1 0. Right? So you have two answers now. One is minus 48 plus 60 by 2. The other one is minus 48 minus 60 by 2. So when you do this, you get 12 by 2. So that is 6. This is one answer you are getting. And the other one is you are getting minus 108 by 2. Right? Minus 108 by 2 will give you minus 54, and speed can never be negative, right? So if it was a normal number, just an equation and you're solving it, you will write both of them as the answer. But this is a speed problem, and it's a real life problem, and the speed can never be negative, right? So we will neglect this, okay? So see, I have written neglected because speed can't be negative. Understood? So you will just write that the actual speed is actually 6 kilometers per hour. So speed of a stream is equals to 6 kilometers per hour. That's your answer. Okay. Now come to the next question. 1 minute. I'll just erase this. This is not required. Okay, so now we will do few problems from the exercise. Okay, so there is exercise 10.5. So see, I'm just doing problems randomly. I won't be solving all the problems, so you can just try. It's the similar problems, you can do it. Okay, so look at question number 4 of exercise 10.3, not 5, it's 3, exercise 10.3. Okay, so the sum of reciprocals of Rahman's age in years 3 years ago and 5 years from now is 1 by 3. Find his present age. So they are saying find his present age. So what will we do? We will say that let Rahman's present age be x years. Okay. Now they are saying 3 years ago. They are talking about 3 years ago. So 3 years ago his age would have been x minus 3. Right. Now whatever his age is, that many years lesser, 3 less than this present age, right? And 5 years later his age will be x plus 5, right? Now they are saying the reciprocals. So what do you mean by reciprocals? You'll have to write 1 over x minus 3 and 1 over x plus 5. So the sum of means you are supposed to add the reciprocal. So 1 over x minus 3 plus 1 over x plus 5 added, both of them added together is given as, it is 1 over 3. Okay, is equals to 1 over 3. Now we need to solve this. So again you make the denominators common. So you multiply x plus 5 over here and x minus 3 over here. So you get x plus 5 plus x minus 3 divided by x minus 3 into x plus 5 is equals to 1 by 3. Now you can say x plus 5 plus x minus 3, the whole thing divided by, you can just solve this, x square plus 5x minus 3x minus 15. You know how to solve this, I hope. In 8th grade you would have learned this. So this is equals to 1 over 3. Now x plus x is 2x plus 5 minus 3 is 2 divided by x square. So this is 5 minus 3 is 2x minus 15 is equals to 1 by 3. Now you can cross multiply both of them. Okay, so that gives you so that gives you x square plus 2x minus 15 multiplied by 1 gives you as it is, and then 3 has to be multiplied by this 2x plus 2. So 3 2s are 6x plus 3 2s are 6 again. Okay, now bring everything to one side and combine the like terms. So you get x square plus 2x minus 15 minus 6x and minus 6, okay, is equals to 0. So x square, now 2x minus 6x is going to give you minus 4x, minus 15 and minus 6 is going to give you minus 21. Okay, so now you can see, you can do the factoring method here. 21 could be written as minus 7 into 3 and minus 4 could be written as minus 7 plus 3, right? So yeah, so here this is a splitting the middle term. So I'm going to give you a shortcut method. Okay, see, when they are actually asking you to solve using the splitting the middle term, you will have to show the whole process. But when this particular splitting the middle term turns out to be a part of a question, now you see this is such a big problem and you're solving so much, and then this splitting the middle term turns out to be just last few steps, right? So in that case, instead of wasting time doing the splitting the middle term, you can just do one thing directly. See, this particular method, what I'm going to say, it's used only for the ones where you have the x square alone, you don't have any number attached to this x square. Okay, when there is no number in front of x square, and you can just use this particular method. After you find out that it's minus 7 and 3, you just write directly x with the minus 7 and x plus 3. So you can, if you want at home, you can try out the splitting the middle term like how I have taught and see if you get this answer. So to avoid just 1 or 2 steps, I have told you this. Okay, but remember, this can be done only if x square doesn't have any number over here. Okay, so you get x minus 7 times x plus 3 equals 0, or x minus 7 equals to 0, or x plus 3 equals to 0. So you get x equals to 7 and x equals to minus 3. Now again, age cannot be minus 3, right? We have actually assumed x to be his present age. How can a present age be minus 3, right? You can't have minus 3 years. So then you have x is equals to 7 as the actual this thing. Okay, so now you complete question number 4 to question number 7 in your classwork. All right, see you in the next video. Allah Hafiz. Thank you.